And start broadcast.
The broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, thanks for joining. My name is Colin Hyduk, and here we have Rachel Swindle giving a presentation on LINKPlanner. So here we go. Rachel, it's all you.
Hi Colin, thank you for that. Welcome everybody, and thank you for joining this webinar. Today we're going to focus on a number of new products since our last LINKPlanner webinar in June. If you want a general overview of how to use LINKPlanner, we have a webinar that we recorded back in January that's still available on the Cambium community forum. It's called Planning Networks with LINKPlanner. So if you want to take a look and get something that's a more overview about how to use LINKPlanner, then please take a look at that one. So if we just take a quick look at the agenda, we've introduced quite a few new products into LINKPlanner in the last couple of months. So we'll focus on some of these and take a deeper dive into them to see what's new. And then I'm going to finish off with a couple of topics to help you get the best out of LINKPlanner. So just a quick overview of all the products we support in LINKPlanner. The ones highlighted in blue are the new ones that we're going to be looking at today. So we've added the N500 from the new CN Reach family. That's just been launched just in about the last hour. Check out the Cambium website for more details on this new and exciting product as we step into the Internet of Things. We've also expanded our PMP portfolio of products with the ePMP 2000, the PMP 450M, and the high-capacity multipoint feature on the PTP 700 product. You'll see in there that we've still got the PTP 250, 500, 300, and the 600. Although those products have now been discontinued, they're still in LINKPlanner for those of you who have existing networks on those products. So let's move along now to the new products. And the first of these I want to have a look at is the PMP 450M. This is the latest in our enhancement to the PMP 450 family and is powered by the new innovative Medusa technology. Despite the complexity of the new technology, in LINKPlanner it's very similar to planning the rest of the PMP 450 family. There is a new menu option for selecting the operating mode, which we'll discuss in more detail shortly. Due to the way that the MU-MIMO antenna system works, we've also changed so that we actually configure the EIRP rather than transmit power, and this is what you'll also see when you're setting it up on the radio. But in reality that's all that's going to be different for you to see when you set up the PMP 450M instead of the other PMP 450 products, and it can connect to the same set of 450 subscribers that you can already use today. So we can plan the PMP 450M in two ways. In sector mode, the downlink uses the same capacity algorithm as the PMP 450 and PMP 450i, i.e. we're just serving a single SM at a time, and for PMP 450M we're calling this the legacy mode. Any changes you see in downlink performance between PMP 450, 450i and the 450M are due to changes in the antenna pattern or EIRP levels. On the uplink, the PMP 450M is always using multiple beams, and this usually improves the modulation mode that can be used for a given receive level. The PMP 450M will often show a reasonable improvement in uplink throughput when compared with PMP 450 and a small improvement over the 450i. But if your existing network's already using 256 QAM in the uplink, then this is the maximum that can be achieved and there'll be no improvement. When you set the operating mode to downlink MU-MIMO, then this switches on the Medusa MU-MIMO technology in the downlink. And at this time we can now use multiple SMs and serve them simultaneously. That gives an improvement in the overall AP downlink throughput. The uplink works the same as for sector mode, so you shouldn't see any difference as you switch between sector mode and downlink MU-MIMO mode on the uplink. The amount of downlink throughput improvement that you can get on an AP is dependent on a couple of other parameters. The major influence is the distribution of the SMs across the sector. To serve multiple SMs simultaneously, they have to be separated in angle so that a different beam can be formed to each SM. If the sector has clusters of SMs close together in angle, even if they're at different ranges from the AP, so may not seem that physically close to each other, this makes it harder to group multiple SMs together and will reduce the throughput improvement. Any high priority channels on an SM are currently only transmitted in legacy mode, i.e. they can only be served individually, so the throughput to these SMs will be at the same rate as in current PMP 450, 450i APs. Therefore, if there are a lot of high priority VCs active on a sector, this will also reduce the improvements seen on an AP when you switch on the downlink MU-MIMO operation. You can see the impact of the downlink MU-MIMO by comparing the downlink throughput values in the AP performance summary. So when you start off by setting the operating mode to sector mode, which will give you the results that we see in the top panel here, 34.35 megabits per second. And then if you change it to switch on the downlink MU-MIMO mode, then we can see quite an improvement in here where it goes up to 74. It is actually also quite normal though to see a small reduction in the modulation modes used. This is due to a small increase in the noise level as we're transmitting different data to multiple SMs simultaneously. However, the overall effect is an increase in throughput as the AP can cycle through the SMs more quickly as it serves multiple SMs in each time slot. This may appear to cause a slight drop in peak instantaneous throughput to a given SM, but the longer term average will be higher. The high capacity, now we'll move on to the PTP700, and the high capacity multipoint feature on the PTP700 allows it to operate in a point-to-multipoint format, which is a limited version of a PMP system. So in LINKPlanner, we've used the PMP side of LINKPlanner to model this. This allows us to get the sector antenna gain to be applied correctly and also to be able to show the paths to the different slaves. It does mean that we have a slight difference in terms used between what you see on the product and what you might be used to as a PTP700 and what you see in LINKPlanner when you move to PMP mode. The product uses the master to control the connection to multiple slaves, and hence the master will be modeled in LINKPlanner as the access point. The slaves will be modeled using the subscriber modules. So, we're going to have a slight difference in terms there. You can still set up most of the same parameters in HCMP mode that you're used to doing on a PTP700. However, you can't use E1T1 traffic in HCMP mode, and in the current release it only supports symmetric operation. When you configure a PTP700 as a master using the access point equipment section, you'll see, as we just said, most of the same options that you're used to on the PTP700. However, there are a few new ones which are specific to point-to-multipoint operation. You need to configure the max range, so we'll be using this SM range parameter. This value needs to be large enough to reach the furthest slave to be connected and affects the timing of the TDD cycle. This range is indicated in the map view by the arc of the sector, and if a slave is beyond the edge of the arc, it can't be connected to the master. You also need to configure the max number of slaves allowed. This maximum is dependent on the bandwidth and the SM range. A 10 MHz bandwidth can only support 2 slaves. For other bandwidths, once the SM range is 25 kilometers or 15 miles or more, then only 3 slaves can be supported. Otherwise, we can support up to the maximum of 4 shown. This value is expected to increase in future releases of the product. Unlike our other PMP systems, in HCMP, a dedicated pipe is permanently allocated to each slave in the max slaves allowed list. Therefore, if this value is set to 4, but only 2 slaves are connected, the throughput will be lower to those slaves than if the max slaves allowed was set to 2. This can be useful if initially you only have a couple of devices but expect to have more later and don't want to reduce their data rate. But if set incorrectly, it can also waste resources, reducing the overall throughput to each device. We also have another parameter at the bottom here, which is the ATPC HCMP master target receive power, which is quite a mouthful. This is actually the same functionality as the SM receive target level in our other PMP products. It sets the target level at the master for the receive level from each slave, hence controlling the slave transmit power to ensure that it doesn't come in too strong. If you set this value higher than -56 dBm, then it will reduce the sensitivity of the master, as the master has a limited dynamic range to support all the slaves. This will affect the fade margin to each slave and may limit the performance of any weak slaves. When you are configuring the slave using the subscriber module equipment, many of the parameters must be the same as the master and therefore can't be changed on this page. They're shown here though so that it's easy to see how the slave is configured and you don't have to keep going back to the master to see what the settings are. A key parameter on this page is the AP antenna gain parameter, highlighted on the edge. This shows the gain of the sector antenna in the direction of this particular device. As each device will not see the peak gain of the sector, it will depend on where in the sector the device is. When you're on the subscriber module page, you can see the performance of the link between the master and that slave. It's very similar to the way we show it on an individual PTP link. The main difference is that in the performance summary, the user sets the minimum modulation mode that's required for the link, rather than the data rate. The predicted availability then shown for that link is then the availability of that min mod mode required. The max usable mode is the highest modulation mode that can achieve the min availability required that's been defined. The performance details panel shows the data rate for each direction of the link for each modulation mode. On the access point page, we also have a performance summary section. This shows how many devices are using each modulation mode in each direction, and shows the aggregate data rate at the master of the links to all those devices. Where there are multiple devices on the same modulation mode, the data rate to each device will be the total shown divided by the number of devices in that mode. So the next new product that we've introduced is the ePMP 2000. This is a recent addition to the ePMP family, and it's only available as an access point in the 5.1 to 5.8 GHz bands. In LINKPlanner, it's selected and configured exactly the same as for an ePMP 1000 and supports all the same SM product options as the ePMP 1000. The key benefits of the ePMP 2000 are on its ability to handle interference, but unfortunately we don't yet have the functionality in LINKPlanner to run interference analysis. We are working on it. It is likely that in a noisy environment, the ePMP 2000 will see a lower noise level than the ePMP 1000, and this can be modelled in LINKPlanner by reducing the interference at the AP compared with the ePMP 1000. If the interference is coming from a specific direction, then SMs in another direction should see a significant improvement. However, if the interference is in the same direction as the given SM, the beamforming cannot reduce the level of that interference. And this makes it difficult at the moment for us to actually be able to estimate that interference in LINKPlanner until we can take account of the other APs and SMs in the network. The smart antenna is not automatically added to the BOM when an ePMP 2000 is selected, because it's possible to buy the ePMP 2000 as a similar unit to the ePMP 1000, and the smart antenna is an optional extra. So we have it available through the optional extras, where it is shown at the top of the page as a recommended addition. And now we move on to the latest product in our portfolio. This will be in the new version of LINKPlanner v4.4.1, which will be released this week, and as I said earlier, it is literally just been launched today. This release of LINKPlanner will add the N500, which is the variant of the CN Reach family that's coming in at this time, at 900 megs for the United States in PTP mode. We will be adding the PMP mode of operation very shortly. In LINKPlanner in the PTP side, select the 0.9 GHz band, and the N500 will be available as a product option. In the United States at 900 MHz, the N500 supports both the licensed and the ISM bands, which means as you plan the links, depending on which band setting you select, you'll see different features, some of which will be similar to our other unlicensed products, and some of them will be similar to our licensed products. This product is also available in Canada, where it uses the same regulatory rules as the United States, so it can be planned in LINKPlanner at the moment using the United States country setting. There are several equipment options which are common to both the ISM and licensed bands, and these are selected through the region and equipment selection. The I/O connectivity options don't affect the performance predictions in LINKPlanner, but they do change the radios that are added to the BOM. The radio comes in two formats, a standard format and an expanded version, which has an additional I/O port on the side. For each format, the radio is also available as either a single or dual radio. In this release of LINKPlanner, we're only supporting configurations which will automatically put the single radio into the BOM. If you want to have the dual radio instead, you can change the BOM and select the dual radios from the optional extras under a category called CN Reach radios. Select the item required and it will be added to the BOM, but you'll need to manually adjust the quantities of both a new item and the existing items. Where there are multiple links from a common location, it may be necessary to synchronize the links. The N500 can either generate an internal sync or use an external source. As you will see later, you can also configure the packet size through the payload bytes feature, which controls the time slot duration. When dynamic payload is switched on, if the access point doesn't have enough data to send to fill the packet size, then this can be reduced and allocated to the other direction instead. This obviously changes the amount of time that each end of the link is transmitting. Therefore, it can't be used when the synchronize feature is enabled, which will fix the transmit and receive allocation across multiple links. At the moment, this is an information parameter only, and it doesn't affect the predicted performance. The N500 uses the same terminology for each end of the link for both PTP and PMP modes. So once again, we've got a slight difference in terminology when we're looking at this product compared to what you might see in LINKPlanner. So one end of the link is always referred to as an access point. In PTP mode in LINKPlanner, this will be shown as the master. The other ends of the link are known as endpoints. In LINKPlanner, these will be the slaves in PTP mode or the subscriber modules when we bring it into the PMP mode. So if we want to actually then configure it for the ISM, we need to use the band setting option, and where we can choose between the ISM and licensed bands. This will then change the menu options you see for the following configurations. The ISM band uses frequency hopping in either frequency hopping spread spectrum, FHSS, or digital transmission systems, although there is a mode of the DTS that can also work as a fixed frequency. Use the modulation type function to select the different options. This will group the modulation modes to allow adaptive modulation to work within a common group. The radio can adapt between up to 4 consecutive modes within a group. If the modulation type is set to FHSS, then the radio has to use a pseudo-random hopping sequence, and which is why the defined hop pattern is set to 1 with no options. If you change to DTS modes, then you will see other options for the hop pattern become available. A value of 0 will mean that it will use a fixed frequency. Values from 2 to 9 will use a uniform step through the frequency list, where the step size is determined by the hop pattern value. In the ISM band, you also need to configure the frequency ranges. So there's a new frequency configuration panel. The band start and band stop values determine the lower and upper edges of the band, and all frequencies channels that are going to be used in the hop pattern must be inside this range. It is also possible to exclude a range of frequencies. For example, if there's another equipment near you which is only using a small part of the band, we can choose to exclude that part of the band. If the exclude lower and upper values are set to 0 as shown here, then no frequencies will be excluded. Otherwise, exclude lower must have a value between the band start and band stop, and then the exclude upper must have a value between the value set for the exclude lower and the band stop. If instead of the ISM band we want to configure the 900 MHz to work in the license side of the band, then you'll see a lot of configuration options there which are all very similar to ones that are already used by other PTP products. So we won't go through those in detail now. The one thing you do have to see if you're used to setting up a license band link is that you will set up the master as well as the high-low frequency options. These are completely independent settings. Which end of the link is the master is independent from which end of the link takes the high end of the frequency band. There are a couple of other settings in the configuration at each end section which are worth highlighting. These are common to both the licensed and the ISM bands. The user limit for the maximum power is defined in milliwatts for this product, which is the value that you will enter on the UI when you're commissioning it. In LINKPlanner, we then convert it into dBm to use as we would do for the other products. Even if a user limit hasn't been defined and you can only see a dBm limit on the UI screen here, the installation report will still do the conversion for you to provide the required value in milliwatts to be used during commissioning. The user can also select the max payload bytes. This is the equivalent of choosing a maximum packet size that the product will use. LINKPlanner will default to the upper limit of 1600 bytes. The lower limit that can be used is dependent on the maximum and minimum modulation mode selected, and will go as low as 64 bytes. The lower limit for the link will be shown in the hover help. The two directions of the link also don't have to have the same value. If you do reduce the value from the 1600 bytes, which can be necessary at times to help get packets through more quickly, if you're in an area with a lot of interference. But if you do reduce this value, then the data rates will be reduced from those shown against each modulation mode. In a future release, we're hoping to be able to give more guidance on the impact of these selections. So then we move down and we can see the performance summary. This looks very similar again to those of you used to using other P2P links for other products. The only one thing to note here is that we've now moved down into the kilobits per second region and not megabits, and we've also adjusted the min IP required and min of IP availability required, so you do just have to adjust your scaling a little bit when you're looking at these charts. So that concludes the information on the different new products, and we'll just in this last section we'll just take a quick look at a couple of different things that will hopefully improve the way you use LINKPlanner. The first one I want to look at is optimizing access points. And we do this by looking at the tilt of the antenna. This has become more important as Cambium have introduced new antennas recently. The initial sector antennas used for ePMP and PMP 450 didn't include any electrical tilt, which means that the peak of beam was parallel to the ground if the antenna was installed without any mechanical tilt. The new Cambium sector antenna, which has been introduced for ePMP 1000, ePMP 2000 and PMP 450i, as well as the new PMP 450M sector antenna, both have approximately 2-degree electrical down tilt. As this very simple image shows, this means that if you mount the antenna so that the back of the antenna is vertical such that it has no mechanical tilt, the peak of beam is no longer parallel to the ground, but is now already pointing down towards the ground by the amount of the tilt. This image is a rather exaggerated one that shows a lot more than 2-degree down tilt. But it does mean that when we're planning with these antennas, we need to take a lot more care about the tilt angle that is used. So we'll now look at an example. So in this example, I've taken a PMP 450i using the original 90-degree sector antenna. For this sector, I've optimized the throughput by adjusting the antenna tilt value. And for this range of subscribers on this particular sector, we have a peak throughput on the AP when the antenna has a mechanical tilt of -1.5, which is, in other words, 1.5 degrees of down tilt. Now remember this total throughput figure in the bottom right-hand corner of 102.01 megabits per second. If all we do to this sector is then change the antenna from the previous 90-degree sector to the new Cambium sector antenna, we make no other changes at all to it, and we don't change the mechanical tilt, we can see that we have quite a big impact on the throughput of this sector. It reduces down from 102.1 to 85 megabits per second, which could make you feel that this new antenna seems a bit disappointing, as it's quite a significant drop. What you can also see on this chart though is that I've shown the hover help that's visible on the antenna tilt parameter. If you select an antenna which has electrical tilt, that will be shown in that hover help just below the mechanical tilt range. And what we need to remember is that we've now changed this antenna to an antenna with 2-degree electrical down tilt, but we've still got in 1.5 degrees of mechanical down tilt as well. So what we need to do now is to optimize this sector for this new antenna. And so in this slide, I have adjusted the tilt until I have again got a peak value on the AP throughput. And we can see here that changing the mechanical tilt now back to 0 degrees, so we're taking out the 1.5 degrees of down tilt, we've now increased the performance of this sector up to 106.82 megabits per second. This is a significant improvement over the 85 we saw on the previous chart, and we're showing a slight improvement compared with the original 90-degree sector antenna. So a quick roundup of these points then. When you're designing an access point, always take note of the electrical and mechanical tilt parameters of the antenna. If there's any electrical tilt, we will show it in the hover help. Always adjust the antenna tilt and take note of the change in the total throughput. Keep adjusting this value until you find the peak value of the total throughput. If there is a slight change, there is a slight change in the electrical tilt across the frequency band. So although the amount of electrical tilt is a good estimate of how much you may need to adjust the antenna by, you do need to check either side of this, as the peak performance is dependent on the local subscriber population and the frequency. So don't just assume a fixed offset and always put that in. On some sectors you also may have important or very high usage customers, and it may be appropriate to optimize performance to those customers, even if it doesn't give an absolute overall peak throughput on the AP. Where we're also seeing a need to go through this process is if you have sectors which are already planned or deployed with PMP 450 with original antennas, and you want to look at the improvement in performance you may get by switching to PMP 450M with its antenna with the down tilt, then you need to do more than just change the product from PMP 450 to PMP 450M. You need to also adjust the tilt, otherwise you won't be seeing the best that the 450M can give you. And finally, the last thing I'd like to talk about is a little bit on the reports. In LINKPlanner you can create both the proposal and sales and the installation reports from various levels in LINKPlanner. They can be created either by selecting the appropriate option from the File menu or by using the icons in the toolbar. Note that when you're in the File menu, you only have access to the options that are selected in the navigation tree. For example, to create the report at the access point level, you need to have selected an access point for it to know which one to use to create that report. But a couple of cautions. When you create the reports from the File menu, it's easier to see what level of report you're creating. However, when you click the report icon, it's quite easy to be at a different level in the project tree than you thought you were. We're seeing an increase in the size of projects, and this means that the reports can get very large, running into thousands of pages. These large reports obviously take quite a long time to create, or may run out of memory before you get there. In the new release of LINKPlanner v4.4.1, we've added a warning to larger reports. This is to give you an estimate of the number of pages so that it will jog your memory before you actually commit to creating the report, and it will give you a chance to cancel the report creation process without having to wait for it to fail first. We cannot predict exactly what size report can be generated on each machine, as it depends on the configuration of machine, what else is running, and using the available memory. So it will be up to you to understand what you can and can't create. But we're hoping that this will give you a little bit of a guide and will give you a chance to back out when you didn't really actually mean to create a several thousand page report. We're working on some other features to optimize the report process as well, so keep your eye on new releases coming up. So Cambium has a presence across social media, and you can keep up to date using any of the methods shown below, so keep an eye on those things. And we also can share ideas. We have an active community forum section on our website and keep up to date with the latest happenings. There are specific LINKPlanner sections to the forum and the knowledge base, which you can follow. We post information on new releases to the forum, so when you download the new versions of LINKPlanner, there's a very formalized set of release notes, but we try and put a post on the forum which puts a little bit more background behind the features, and so that's always a good thing to have a look at when a new release comes out. In the knowledge base, you'll also find articles on many of the LINKPlanner features. If you have ideas for other topics you'd like us to cover in the knowledge base, do let us know, or post your ideas for feature enhancements or any general queries you have. Don't forget that we also have the LINKPlanner email address, which is on the front page when you first start LINKPlanner, or it's in our LINKPlanner user guide. We do reply to all emails we receive. And that's the end of my presentation today, so thank you very much for your time. And I hope you enjoy the new version of LINKPlanner when it's released this week.